Okay, answering this question, what you've got is some oil floating on water. Okay, and what happens is you've got light, monochromatic light incoming. Some of that light bounces off the surface, reflects off the surface. Some of that light enters the oil and refracts. You've got the oil water surface here, and rather than the light passing through into water, the light has totally internally reflected on this surface, made its way back to the air oil boundary, and then refracted outwards. Okay, so that's what's happened to the ray of light. It's split. Some of it's been reflected on the air oil boundary, some of it's gone through and then reflected later on at the oil water boundary and then refracted and come out. Now, you see these rays as parallel, but they say that it produces an interference pattern that implies that these two rays at some distance far away they will meet and hence and interfere. Okay, now what we're going to look at is how they produce an interference pattern. So we know that constructive interference, so these two rays can constructively interfere somewhere over here, and we know that the path difference between this and this will be a whole number of wavelengths if it was constructive interference. And if these two rays meet somewhere down here and the path difference is in the order of half wavelengths, then you're going to get destructive interference where where you'll have no light. So those are your two possibilities. So why would you get this path difference? Okay, where does that come from? Because the rays all originate from the single source. So this ray is traveling this distance here. This ray also splits and travels this, and this distance. So the rays are traveling along here. So the distance from here to here for both possibilities, this possibility and this possibility, are the same. It's only when you get to this point, one of the rays is traveling ahead of the other one. So this one flies off that way, this one goes in, hits our boundary, and then flies off that way. So we know that the refracted ray travels this additional distance, this distance. In the time that this ray does this and this reflected ray would have got up to this point here. Okay, because if you look at that distance, that there and that there are the same distance, and if you meet up here, this distance and this distance will be equidistant, and that's why I put a 90-degree position there, because I know everything beyond that, these two rays will travel the same distance. So that means that the reflected ray travels this distance, and the refracted ray in addition travels this distance. And if this ray, this plus this minus this is the difference in the path, is equal to a whole number of wavelengths, then you get constructive interference. If this distance minus these two distances, that will be the path difference between the rays that meet further up. If that's in order of half a wavelength, then you'll get destructive interference. So how would you answer this question? It's 5 marks. Okay, so the first mark will be considering that light hits the air oil boundary and reflects. Second mark, it also some part of that light will enter the oil and refract. At the oil-water boundary, what do we get? Total internal reflection. And then the next mark will be the air-oil boundary. The light will refract out, and the reflected ray and the refracted ray will meet at some distance and superpose and interfere. And then you finish that off with saying if the path difference is whole number of wavelengths, then you get constructive interference, and if the path is a half in order of half a wavelength, then you get destructive interference. Now, you don't specifically have to put this stuff in there, but what you must mention whenever we get interference pattern is that there are bright regions and dark regions. So that means that when this light angle changes, these distances will change as well. And then it just so may happen to be that you'll get constructive interference of one angle, and then if you change this angle slightly, you might get destructive interference for a different position. Okay, hope that helps.